notice, and this is the typical copyright. We continue with syllabus for mathematics, CSEC, which became effective in May-June 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards. The main planned change of this exam is to split it into 2 parts. Please note down here, this is the 15th of 26 video. It should have been 15 of 24, but I had to split this objective into 3 videos. As you could see here, that was video 14. Now, these 3 objectives, I had hoped to do them in 1 video, but that video will run for about nearly 2 hours. So I am doing video 15 on this one only. Video 16 will be that one, and video 17, that one. So this is where the problem arose. Instead of doing 1 video here, I'm now doing 3. This is video 15. But then I also have a 16 and a 17, so 2 additional videos, which sent it up from 24 to 26. Those are all published in their entirety. These are published partially. We are now here, video 15. When this is finished, it will be published partially. As it relates to the rest of the video in this section, these others will be published in their entirety, and those partially published. In the last video, video 14, in Objective 7, we already talked about translation. So that is finished. In this video, we have to deal with these 3. This one is not required by CSEC. I will quickly scroll through most of the typical introductions. Exam structure, the importance of section 1 and its use even within the primary school level. Section 2, all published. Section 3, all published. Section 4, some published and others partially. Section 5, same thing. Section 6, some videos published in their entirety, others partially. Section 7, same principle, some published in their entirety, others partially. Recommended textbook from CSEC, and the 2 that I would recommend out of those, a very useful website to help you with paper 2 math questions. This formula sheet will be provided in the exam. Section 8, we completed up to this one, which is translation using column matrix. So essentially we finished that. And then after that, we need to go on to Objective 17. As I pointed out, those above there already completed and published entirety or partially. These others are yet to be published and completed. So we are here. This is video 15. That part of this objective is finished. That part in Objective 7. So we are left with these 3 for this 1 video. Those 2 are not required by CSEC. So we are going to talk about reflection, rotation, and enlargement in this 1 video. Now, the glossary of the syllabus does not define reflection nor enlargement, though it does include rotate as here. We will come back to this after we finish with reflection. So rotate, nothing on enlargement. So let's begin with reflection. A reflection is a geometric transformation that flips a shape over a specific line, and that line is called a line or the axis of reflection, or simpler, mirror line, to create a perfect mirror image. The reflected shape remains the same size and shape, but its orientation is flipped laterally. That is to say, left becomes right. If you look at this, you have an object here. This is the mirror line here. This over here is the image. That image is the same size and shape as the object, but it is flipped laterally. So the image is the same size as the object. The image distance is the same as the object distance. In other words, from that point to the mirror is the same as from this point to the mirror line, and so on. Thirdly, the image is laterally inverted, as I pointed out before. Left becomes right, right becomes left. Now, if you are doing physics, you don't need this for math, but if you are doing physics, you also need to know that the image is virtual. It is not caused by actual light rays. Now, there are a number of situations we have to look at. For situation A, x is equal to 0. That is y acts as the mirror line. First of all, we'll do it graphically without reference to coordinates, and then we'll see how it can be calculated. So if that is the mirror line, this is the object. We want to find the image graphically. What you will do is draw a line going straight across here. Make sure that line is perpendicular to the mirror line. Measure the distance from here or count the number of squares, and then measure that same distance or count the same number of squares to that point, which would give us A prime. Well, you would do the same thing for D. From here to there, the same distance, mark it off to this point or count it off, which would give you D prime. Now, in the case of B and C, you have one line coming across. So let's take the distance from C to the mirror and take that same distance out here, which would give us C prime. And then we go back to B. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which is here, which is B prime. Now, once you have those image points based on the object, you join them and complete the image, which is this as the image. This is what you will do for all such situations, irrespective of what the mirror line is. Now, that is graphically. If you have the image and you want to find the object, you will reverse that process. Now, we are going to do this by calculation, if we have the coordinates, or maybe if we have to do this without the graph. So let us say you know these coordinates of the vertices of the object. How can we obtain the coordinates of the vertices of the image? By calculation. So when x is equal to 0, meaning that we are using the y as the mirror line, what happens is that you convert each point from the object using this system for the image. That is to say, you keep x and y the same, but make x negative. Or you multiply the x by -1. So let's see carefully what happened here. If we do the calculation, you notice the y values do not change. The y values stay the same. You multiply whatever the x value on the object is by -1. So this -5 would become +5, and so on. All of these, you have to multiply them by -1. And so we have those coordinates. Let's plot them and draw in the image. Now, this is what happens whenever x is equal to 0, that is to say, the mirror line is y. Whenever x is equal to 0, the mirror line is y. This is what always happens. Of course, if you have to go the other way around, you would keep the y values the same and then divide the x values by -1. That is situation A, by calculation and previously by drawing. Now let's go to situation B, where y is equal to 0. Now x is the mirror line. X is the mirror line here. Y is equal to 0, x is the mirror line. Let's do it graphically first of all. You draw a perpendicular from A to that, extend it the same amount from here to there, over on the other side, and that there would be A prime. Obviously, you do the same thing with B, that will be B prime, the same thing with C, to be C prime, and the same thing with D, which would give us D prime. Now that you have those 4 coordinates for the image, you just connect them up with straight lines and you will get the image like that. That is what you will always do graphically. Make sure that these lines are at right angles to the mirror line in all situations, no exception. Of course, if you are given an image and you want to find the object, you just reverse the process. Now, let's do this by calculation using coordinates. So we have coordinates now. That is the mirror line. What formula will we use? Well, when y is equal to 0 and we are taking the mirror image, each point on the object becomes basically the same thing, except the y values are now negative on the image. Or you just multiply all the y values by -1. So if we do that, we get this table here. Notice that now the y values are multiplied by -1. The x values stay the same. If we plot those points, 17, 11 becomes 17, -11. That's A becomes A prime, 17, -11. And of course, we do the same thing for B prime, C prime, and D prime. Join all of those points and we get back the same image as we had when we did it graphically. That is situation B. We do have quite a number of these situations to deal with. Of course, if you are given the image and you have to find the object, you reverse that process. Keep x the same, and then the y values that you have, you could divide by -1 or multiply by -1, you get the same answer. Now let's look at situation C, where y is equal to x as the mirror line. Y is equal to x. It's a line going across like this at 45 degrees. As if y is equal to x, then when x is 5, y is also 5. So you get that line that is 45 degrees slanting upwards from left to right. This is our object. If we do this graphically, first of all, we draw a line from A to cross the mirror line at 90 degrees. And we measure from here, from A to the mirror line, same amount to A prime on this side. You do that for A. You do the same thing for B. And then you do the same thing for C. So now that you have A prime, B prime, and C prime, you just join the points and you have the image. Remember I said this is what you will always do, irrespective of what the object is or what the mirror line is. You want to find the image. Or you go the other way around if you have the image and you want to find the object. Now let's see how this can be done using calculations of the coordinates. If we put in some coordinates here, what formula will we use? Well, when y is equal to x as the mirror line, then points on the object will map onto points of the image as yx. You change around these values. You switch around the elements of each coordinate. So this negative 6, 8 would become 8, negative 6. So negative 6, 8 will become 8, negative 6, and so on. Let's plot them. This one here is A prime. That there is B prime. And this here is C prime. Remember, you switch this around. Negative 1, 5. You switch the elements of the coordinates. Finish drawing the image, and that's what you have. Now remember, this holds true only when y is equal to x.